In this video, we're going to talk about derivatives and how to use the quotient rule. The quotient rule says that if you have a function you're trying to take the derivative of and you can separate it out into the numerator and the denominator, you can say that the derivative is equal to the denominator function times the derivative of the numerator function minus the numerator function times the derivative of the denominator function all over the denominator function squared. Now, if we want to do an example for this, let's look at the derivative with respect to x of x divided by sine x. Well, the first thing that's convenient to do is go ahead and write down what function is what. So we'll say f of x can be equal to x, and g of x can equal sine of x. Go ahead and take the derivatives of each of those separately to get f prime of x is equal to 1, and g prime of x is equal to cosine of x. This can really help eliminate some mistakes. If you have problems, do these derivatives separately and don't just do them in your head. You might think you know what's going on, but sometimes it can get a little messy, especially using this rule in particular because there's a lot going on. So now we simply need to substitute. So then we get the derivative with respect to x of x divided by sine x equals g of x, just the function, so it's sine x, times the derivative of f of x, which is just 1, minus f of x, which is just x, times the derivative of g of x, which is cosine of x, divided by g of x squared. And that is how you use the quotient rule. And the quotient rule can be sometimes used, but also you might be able to rewrite your function so that you can use the product rule. I know some people prefer that because they are similar. So if you would like to do that, I recommend checking out our video on the product rule. And lastly, there's a memorization trick we can use to remember the quotient rule, and that is low d high minus high d low over low squared. And I have that wrote out here, and let's go through it really quickly to kind of understand what it means. Well, low is just equal to the denominator. High is going to be our numerator. And this is of the original function. And then the d equals the derivative of that function. So if we look at that, we have the low times the derivative of our high minus our high times the derivative of our low, and then that's all over low squared. So that's one way you can kind of remember this that might be a little bit easier than remembering it in the g of f times f prime of x, etc. version.